All right, everyone. So I'm going to go ahead and go over some questions for this test review. I'm not going to do all of them. There are 14 of them, and I don't want this video to be an hour long. So I'm just going to go over about half of them, and hopefully that should help you answer the rest of the questions and get you ready for the test. So the first couple of questions I want to go over are numbers 2 and 4. So if you guys remember with dilation, essentially what I want you to do with a dilation is you're either growing a figure or shrinking a figure, and you're going to be given a scale factor. So here in these problems, they just say, here's a dilation of 1.5. But what we're used to seeing, like in our notes and in our problem set, is we're saying, okay, with a scale factor k of 1.5. All right. So in the past, I had you actually draw these points out and draw the figure yourself by plotting the points and then multiplying whatever the scale factor is. But for right now, I just want you to practice knowing what you're doing. So first of all, if I want to know what is the new v with a scale, after like growing it or enlarging it with a scale factor of 1.5, we're just going to get 1.5 and multiply it by all of those numbers. So I will be nice. I will allow a calculator on this, but keep in mind, sometimes you're not going to be given a calculator for these questions. So let me go ahead and get myself a little bit more comfortable here. So I know for my new v, right, I'm just going to get my scale factor of 1.5 and multiply it to those two numbers. So if I get -2 times 1.5, I get -3. So my new v is at -3, comma, -3. All right, let me get a different calculator. I want to get the one that you guys are mostly going to have. Nope, that one's broken. Here we go. All right, so there's my new v. My new I is going to be located at, I'm going to get my two numbers, 1 and 2. So 1 times 1.5, that's just 1.5. 2 times 1.5, well, if -2 was times 1.5 was -3, this will just be +3. All right. My new f, all right, is, let's see, f of, so 2 and 0. So 2 times 1.5, we already said was 3. 0 times 1.5 is 0. And then finally, my new a, again, this is easy. I'm just getting the number and multiplying them. It's like we're in kindergarten already, all right? We're just multiplying numbers. So then 1.5 times those two would be just +3 and -3. That's all you have to do for those, all right? Now, one of the things that this time you have a k factor of 1/4. All right. So another thing that you're essentially doing is you're getting 1/4 and multiplying it by every single one of those numbers, right? Now, let's say you weren't given a calculator for this. All right. The way that I always tell people to do to work these out is you multiply your number by the numerator and then divide it by the denominator. So technically what you're doing, right, is I'm getting -4, so 4 negative, times the numerator 1, and then divided by the denominator, right? Some people like to view this differently. Some people just say, oh, if I'm multiplying by 1/4, that's like dividing by 4, right? You could just get each of those and divide it by 4. If I'm multiplying by 1/4, that's like multiplying by 0.25. And then they just multiply 0.25 by all of these. Again, there's a lot of ways that you can do it, but your fractions are not always going to be 1 over something. Sometimes you're going to have a fraction with like 3 over something. So I'd rather you get in the habit of multiplying by the numerator and then dividing by the denominator for all of these. All right. So that's what we'll do. My new w is located at -4 times 1 is -4 over 4 is -1. Right. If I do the same thing with -5, that's going to be -5 divided by 4. So it's either -5/4 or I'm just going to do -1.25. Right. My new x, let's see. If I get, same thing with -5. -5 is going to be -1.25. -1 will be -1/4 or -0.25 if I put that in my calculator. Right? And then finally, my new t, if I multiply -3 times 1/4, that'll be -3 times 1 divided by 4 will end up with -0.75. I wish I had more space here, but whatever. And then 0 will just be (0). All right. So that's all you're doing. You're just multiplying your scale factor and you're done, right? By every single one of those numbers, and that gives you your new point. Okay. So now let's go ahead and the next one that I want to do with you guys is number 5. Now on your worksheets, I made a mistake. I accidentally put 3. I forgot to give you what scale factor to use. All right. So hopefully, if you're in class, you'll have paid attention to me telling you that the number 5. I want you to use a scale factor of 3/2, and for number 6, I want you to use a scale factor of 1/2 or 1/2. All right. So if I have a scale factor 3/2, what I'm essentially doing is 3/2 is greater than 1, right? So what I'm essentially doing is I'm enlarging this figure by 3/2, or some of you might think of it as 1.5. So when it comes to this problem, what I think is best to do is first label your points as the coordinates. All right. So when I label these points, I'm going to have R. I know that R is located at 1, 2. Okay. My N, that's located at -1, 1, -1, comma 1. My S is located at 3, -3. And then my M is located at 1, -3. Okay? So again, if I'm using a scale factor of 3/2, okay, what I'm going to do is over here down below, I'm going to make a list of what my new points should be. So obviously I'm going to start with R. So I'm going to have a new R. I'm going to have a new S. I'm going to have a new M. And I'm going to have a new N. And then down here, I'm going to try to be organized with my work. I'm going to go ahead and multiply every single one of these numbers, right, by 3/2. So let's start with R. So I have 1 times 3/2. Well, that's just going to be 3/2, right? So 1 times 3 divided by 2 gives us 1.5. So my new R is 1.5, comma. And then if I do 2 times that, again, 2 times the numerator divided by the denominator. So 2 times 3 divided by 2 gives us 3 right there. So there's going to be my new R. Okay. My new S, I'm going to get those two numbers. And again, just multiply it by 3/2. So I'm going to do 3 times, so hold on, let's start over. 3 times 3 divided by 2 gives us 4.5. So 4.5. And then -3 would just be -4.5. Right? My new M, let's see, I have 1/3. So I already did 1 before. So 1 was 1.5. -3, I already did that too. I -4.5 right there. And then for my new N, well, we already did 1. That was 1.5. So that's -1.5. And then 1 times 3/2 will just be +1.5. All right. So luckily, there's a lot of repetition with the numbers we multiply, so we don't have to sit there and multiply them all out. Now, let me get a different color here. All right. So now that those are my new points, I'm going to go ahead and plot my new points. My new R is at 1.5. So if this is 1 and that's 2, 1.5 is like in between. So 1.5, and then I go up 3. So there's my new R. Okay. And remember, just in case you forgot, when I say new R, I'm going to use the tick mark with that R. Okay. Then I'm going to figure out where my new S is located. So 4.5, -4.5. So let's see. 1, 2, 3, 4. 4.5 is halfway there. And then down 4.5. 1, 2, 3, 4. And then halfway there. So there's my new S. Okay. Then my new M is located at 1.5. So 1 halfway through is 1.5. And then down 1.5 as well. Did I do that right? Oh, 4.5. So over 1.5, down 4.5. So then down 4.5 is like right there. There's my new M. And then for my new N, that's -1.5, +1.5. So there's 1.5 to the left, and then +1.5, 1, +1.5, like right there. Okay. And then there's my new N. And then what you'll notice is, let's see if I can find the little straight edge here. I'll have a better ruler, but whatever, I'll just use this. So then I'm just going to go ahead and draw my figure. And there you go. All I did was I got my original figure and I expanded it out by 3/2. All right. And that's essentially. Oops.
Teachers, at this time, if you haven't already done so, please release all students with WIDA testing passes. Once more, please release all students with WIDA testing passes. Thank you.
All right. So sorry, I'm obviously recording this during first period. But anyway, so there you go. I went ahead and expanded my figure out by that much. All right. So now if I look at number 7, all right. So this one says determine the scale factor used for the transformation below. All right. So you'll notice here that they already drew the 2 figures for you. Now you have to decide what was the K value that they used to make that happen. So if I look over here, one of the things that I always tell students is just pick a point, right? What point do you guys want? I know I told you not to talk, but just tell me a point. Which one? You want to do X? Sure. Let's do X. So if I have X and X prime, so let's see. I'm going to look at X. My original X, the one without the tick mark, is 0, 3. And then when I look at my new X, I go from 0. That looks like it's about 4.5, right? It's like halfway between 4 and 5. Yeah. So it's going to be 0, 4.5. Okay. So now you have to decide, okay, well, in order to get from my old original value to my new value, well, the zeros aren't going to be very helpful. Anything times 0 is just 0, right? But let's look at the actual number. So what times 3, and let me set up a formula here. 3 times what number ended up giving me 4.5, right? Or actually a better way of writing that would have been 3 times what number K or what scale factor gave me 4.5, right? So if I want to figure out what my scale factor is, I just divide both sides by 3. So then K, right, gives me, so 4.5 divided by 3, that's a scale factor of 1.5. Okay, and just a little calculator trick, just in case you guys didn't know this. Sometimes if you want to know what is the fraction version of a number and you have the decimal, right? If I look at this calculator, let me zoom out a little bit. You see that little arrow right there? And you see how above it says F to D, like double arrow? That means from fraction to decimal, or other way around, decimal to fraction. So one of the things you can do is if you press the little, that's in green. So if you want to reverse this from a decimal to a fraction, you can press the second button and then the little arrow, and it'll change it to a fraction. So 1.5 is 1 1/2, right? But sometimes they want the other version of the fraction. So if you want to change it to the other version, you just press second and then this one, second, that, and it's 3/2. So K is equal to 1.5 or 3/2. All right. So that's one way of just a little calculator tricks to kind of help you get by. All right. So I'll let you guys do number 8. Now for the fun stuff. So if we look at the back, the problems that I wanted to do is I want to do numbers 10 and 11. And I'm also going to do number 13 for you guys. All right. So if I look at number 10, it says, let me zoom in a little bit. It says if triangle NML is similar to triangle SRL, find the value of X. So what I always tell you guys to do, right? See how the triangles are oriented differently? Let's instead draw them in the same orientation, like in the same, position. So I'll redraw the big triangle to make it look like the little triangle. So let's draw this little, so I know that this is a bigger version of that. So let me just draw this one, but just bigger. So I'm going to draw it maybe like that, and this is kind of angled down a little bit. So something like that. That's pretty good, right? And so here I have LRS or SRL, right? So I'm gonna ignore this big triangle. And so what I'm going to see, so if this is L, that's also going to be L right there. L corresponds with L since that's the third letter. R is the second letter over here. So the second letter of the other triangle is M. So if R is here, I'm going to put M right there. S is the first letter of this triangle. So that means that the first letter of the other triangle is N. So S and N correspond to each other. So if S is right here, I'm going to put N right there. Right? Then I'm going to kind of copy the values from the original triangle. If I have Ln was 3x minus 1, then Ln over here is also 3x minus 1. And over here I have ML is 28. So ML, this is going to be 28 as well. Perfect. So now that I redrew this triangle, I don't need this triangle at all anymore. I'm just going to cross it off and only work with those two triangles right there. Right? So they're saying find the value of x, and now I can create my proportions, and now I can create my ratios, right? So the first ratio I can already see that 24 corresponds with 28, doesn't it? So in that case, what I can do is I can get 24 divided by 28 and create a ratio from that. That's one of the ratios I'm going to do. And again, the mistake that I know a lot of you are going to make is you have to be consistent, all right? So if over here, obviously I put the value of my small triangle up top and then my big triangle on the bottom, right? That means that my next fraction that I make, the small value goes on the top and the big value goes on the bottom. So when I create my other proportion, the other two sides that I have is I have this one on the bottom and that one on the bottom, right? So I'm going to pick the value of my little triangle, x plus 7 on the top, divided by 3x minus 1 on the bottom. All right. So what I'm going to do over here now is I'm going to go ahead and cross multiply, right? If you ever have one fraction equal to another fraction, make sure you cross multiply. And one of the things that I know people are going to forget is they're going to forget to put and these expressions in parentheses. Please don't do that. All right. I'm going to do 24 times that. So that's going to be 24 in parentheses. I'm going to put 3x minus 1. And I'm going to set that equal to the other part, 28 times parentheses x plus 7. All right. And now this is just going to be some basic algebra. I'm going to go ahead and distribute. 24 times 3 is, oh my God, 72, right? Yeah. 72x minus 24 is equal to, and then I distribute that. So 28x plus 196, I think. Let me double check. 28 times 7. Yeah, 196. Right? And now this is just basic algebra. I'm going to subtract 28x from both sides. At the same time, I'm going to add 24 to both sides. Whoop. Cancel, cancel. 72 minus 28. I don't feel like doing that in my head, so I'll just use my calculator and cheat. So this is 44x is equal to, and then 196 minus 24 gives me 172. So finally, if I want to get x by itself, I divide by 44. And I get x is equal to, so divided by 44. I had x is equal to, let's just say 3.91. I was hoping it would be a nicer decimal. Did I do that right? What's up? Oh, this is plus 24. 196 plus 24 is 220. So divided by 44 is 5. So x is equal to 5. I was going to say, usually the numbers come out nicer. My bad. I subtracted 24 by accident. Thank you for pointing that out. All right. So same thing over here. I'm going to go ahead and I have two different triangles, but we know that they're similar to each other, right? So if they're similar to each other, what I'm going to do is I'm going to get these triangles and orient them differently. So I'm going to forget about this triangle, and I'm going to redraw this one here on the side. So I know I kind of have like more of a vertical here, horizontal there. I'm going to make it upright because this one does look smaller than that one. So I'm going to draw this one smaller. So I know that, let's see. So if I look at J, right? J is the first letter here. D is the first letter of the other triangle. So if J is here, I'm going to put D in that same position. K is the second letter. So E goes where K should be. And then, of course, the last letter is F, right? So I have DE is 10. EF is x plus 11. All right, and there you go. Now I can easily see which two sides of the triangles correspond to each other. So what I'll do is I'll just do the big triangle over little triangle. So I'm going to do 25 divided by 10. And that's going to be equal to, and then again, big triangle over little triangle, 6x plus 3 divided by x plus 11. And then from there, I'm just going to go ahead and cross multiply. So then I have 25 parentheses x plus 11 is equal to 10 times 6x plus 3. Whoops, there you go. All right, and now it's just algebra from here. I'm going to distribute, hopefully I don't screw up this algebra. So I'm going to distribute that and I get 25x plus 25 times 11 is 275 is equal to, I'm going to distribute my 10, so that's 60x plus 30. All right, and now I'm going to go ahead and work this out, subtract 25x from both sides. I always do the big number minus small number to deal with positives. 25, God, that's ugly. 25x on both sides, cancel. Then I'll subtract 30 from both sides. And so let's see, 275 minus 30 is 245. That's equal to 60 minus 25 is 35x. So then to get x by itself, I divide both sides by 35. And then I get x is equal to, so 245 divided by 35, x is equal to 7. Okay? Now, the problem is that's not what the question is asking for. The question is asking find KL. So I know that KL, let's see, KL was 6x plus 3, so it's going to be 6 times 7 plus 3. So that's 42 plus 3 is equal to 45. And that's the answer there. All right. And then I think that's pretty straightforward, right? So then from there, these two problems on the bottom, they're saying determine if the triangles are similar, if possible. Remember how we, like in our notes in the past, we said that there are ways that we can prove that triangles are similar, either through angle, angle, side, 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 or side, angle, side. So that's how we're going to answer these questions, all right? I'm going to look at these triangles and I'm going to say, okay, so are these triangles similar in any way? So first of all, I know that we have an angle that's the same because of vertical angles, right? So I know that angle M is equal to angle M, right? So there we have an angle that's the same. So obviously we're not going to use side, side, side. And now we have to determine, are there any kind of ratios that I can make from here where the ratios are all the same? Okay, so one of the things I'll tell you right now is I can go ahead and, like, you can make a ratio of 28 over 39 over 2. And you can also make a ratio of 15 over 21. But believe it or not, you can also do a ratio of 15 over 39.2 versus 28 over 21, right? So let's go ahead and do that. So if I do 21 over 28, big triangle over, wait, that doesn't make any sense. I'm sorry, hold on. I'm going to do 21 over 15. Sorry. Right? So what ratio do I get from that? So I get 21 divided by 15, I get 1.4. And now let me try this other one. If I do, because again, I did big over little, so I'm going to do big over little, 39.2 divided by 28. Do I at least have two sides that are proportional? So if I do 39.2 divided by 28, I also get 1.4, right? So right there, you have an angle, and then you also have a side that are similar to each other. So here you have a side, an angle, and a side, right? That are so similar by side, angle, side, right? So because they're similar by side, angle, side, well, we know that triangle PKM, right? So if I look at this, I'm going to see that L corresponds with P, so it's going to be L. So triangle L. And I know that Q corresponds with K, so I'm going to put, and K is the second one, I'm going to put Q right there, and then M is M. And so I know that those two triangles are similar by SAS. All right. So those are pretty helpful. I think the most important problems are easily these up here, numbers 9 through 12. I'm definitely going to include a few of those on the test. And then from the front side, these are all extremely important. Scale factors and dilations. So I'm going to leave you guys to it. Hopefully, doing pretty much about half of the problems should be helpful for getting you guys doing the rest of them. And if you have any other questions, just let me know, and then we'll stop it there.